All right, our next speaker is Dr. Darrin Karcher, speaking about visioning with birds. Thank you, Darrin.
Thank you, Shauna. Okay, so actually, Karen teed things up quite well. The other day, I had to go and have some visual acuity done. I'm sure some of you have been there because as I look around the room, I see quite a few of you with glasses. I have my contacts in today. First thing I had to do, right? They do some of the eye measurements. I'm not going to go into that, but then they sit you down in the lovely chair and they say, okay, please read the top line, CB. Can you read the bottom line? Okay, Z something, C something something. Okay, so we got to work a little bit on visual acuity, right? Next thing then was, okay, how about color? Now for me, luckily, it's not something I'm concerned with, but there are some of us that if I ask you to look at this number, some of you may have some color blindness. And so you may struggle to see these different numbers within the circles, right, with the dots, okay? So then usually as you go through this process at the ophthalmologist, they get to the point where they then say, okay, we're gonna see now if we can make you see better. They throw this up and this is what it looks like, and then they go through this really annoying thing that they can only ever count to 8, and they say better 1, better 2, better 1, better 2, and then you're like better 1, and then they go better 3, better 4, better 3, better 4. And eventually they keep going and they keep going, and lo and behold, you can see. And then they tell you, okay, your script has changed, or maybe we need to do a little bit to do something a little bit different so that you can see better. So I got to thinking, what about laying hens, right? What about our birds? Because we're all very quick. As Karen said, we walk in, we measure the lux, and oh my God, the chickens can't see, or it's so bright in here, they still can't see. That's why they're so aggressive. Maybe that's not quite the case. So it started in 2019, and there was a grad student from biology that reached out to me and said, wanted to know if I could get a chicken from you. Okay, sure. What would you like to do? Well, we'd like to be able to see what the chicken sees. So, of course, I'm a little bit intrigued, and I said, okay, I can. The only thing that I have to ask, though, is I need you to introduce me to your advisor, because I would like to talk to him about chicken vision. And so in 2022, they published their work, and the idea is that, maybe we can actually start to visualize how birds see. So that was my introduction to Esteban Fernandez-Urisic, and we started granting, right? Because it is out there. Nobody was doing it anywhere within the poultry world at all. Everybody's looking at light, but nobody's really trying to understand how the birds see. And it took us a very long time, but after like 3-4 years, we finally got something to start to explore this. So the question became, as I'm talking to Esteban, and he was making the comment that realistically, when they look at birds, about 0.3 meters is the difference at which birds start to not be able to see each other. Okay, so right here is where, okay, well, it doesn't show up. So right here, right, is where we start to see that those birds maybe can't tell each other apart. So Esteban was doing some digging then to see what has been published in the literature. And so what do we know about a behavioral point of view for how those birds can view each other? And so we found this paper by Marion Dawkins back in mid-90s, and lo and behold, the answer is the same. So now we're really feeling like we've got something to grasp, right? We know that there's about that 0.3 meters. Birds are maybe struggling to see each other clearly, and there's also behavioral things that are important when birds get beyond that 0.3 meters. So lo and behold then, my colleague Greg Fraley decides he's coming to Purdue, and so hey, Greg, you want to join our team? Come on, we've got some fun things we're doing. And of course, he wants to only look at the brain, which is fine. So it works out well, right? Because as Karen talked about, we've got the visual system. We've also got everything that's going on in the brain and how do all of these pieces interplay together. I had to work really hard to get these two to stand back to back like that just for this one slide. So if we think about it, right now with our laying hens, we are moving into extensive housing. We do not have a one type hen fits all, right? Everybody's playing with certain things, and as a production company, you can figure out that if you take that middle picture, those brown hens are working amazing in this, and we are going to repeat it, and we bring in the exact same strain and we run them again, and it's a complete disaster. So there is no consistency with having a said strain that works. And every genetics company is trying to find what is the strain that can fit in these housing systems. Well, one of the things that we have to accept is that as we have moved away from the conventional cage, which we have been in for over 65 years, we know how to manage that. We are now looking at environments that are more visually complex than that conventional cage. So maybe some of our problems that we see with our mislaid eggs, our keel bone damage, some of those types of issues are because things are so very different, not just from what we visually see, but maybe it's what the birds see. So, we have this great idea, have a good team together, so maybe I should get some more information. So go to Netflix, find this great show, hey kids, come watch this. And so we sit down to watch this and go on about wonderful, amazing things. Want to share my knowledge now with Esteban, who's been doing this for a very long time, and the first thing he says is, well, we know this is fundamentally different. Yep, we know that. Karen talked about it, so just reinforces it. And there's some misconceptions, and perhaps Netflix isn't all it's cracked up to be. First and foremost, yes, we can shine a light on birds and we can get their feathers to glow really pretty like, but in fact, we know that they see differently than us, and so we can't make the assumption just because we see them visualized under a UV light that that is the only way that they look differently. That is not likely the only thing that birds are seeing differently with their flock mates or the others that they're interacting with. So we know that they have these visual pigments, and Karen alluded to that with the oil droplets, and they're going to see so many more colors, and there's probably stuff that we can't even fathom, right? So now think about this. We're going to try to understand how birds see by something that we can't even comprehend seeing. But maybe there is some steps that we can take to start to understand this. So when we look at these photoreceptors, right, we need to understand that for birds, they have 4 of them. And so they have a violet, which is on your left there. Then they have a short, a middle, and a long wavelength. And then additionally, they have this double cone receptor, which is going to be important for movement, okay, achromatic. So when we think about the design on the far left there, we know that as light travels through, it's going to interact with that oil droplet towards the back of the receptor as well as that visual pigment. So when we take a microscope slide like you can see in the middle, and we've circled the different oil droplets that correspond to the different photoreceptors. And so within your field then, you can go in and you can visually count these different photoreceptors that may be present within the various bird eyes that you're looking at. So another way to think about this is that initially when that light is coming through, we know it's going to come in as different visual pigments. We're going to add the oil droplets, which will help us refine some of that wavelength going through. And when we add them all together, we end up that they can actually have a better discrimination of color than what we can as humans. So they have their eyes designed to do some things that we cannot do. All right, so let's talk a little bit about laying hen eyes. So this is preliminary data, and this is getting old saying this because as Greg and I were talking with Shauna last night, this is preliminary data that we're waiting to publish, and we have been sitting on this data for almost 3 years now. And the reason is because we are now 35% of the way of the 12,000 microscope slides that have to physically be counted. And so I have my undergrad army that they love me to death because it's mandatory. They spend at least 2 hours every week counting slides so that we can try to knock this out so we can publish it. But we looked at 3 different ages, so 17, 25, and 85 weeks of age. We did brown and white birds, and they were sisters, housed as identically as could be. So same environment, same feed, same light, everything, so that we could really try to differentiate what are the differences in the eyes and the way that they are put together. And so just to refresh your memory, on the left there, we have the light coming in through the cornea. The lens concentrates it. It is going to be filtered through the vitreous humor, and then it hits our retina. And then just to break it down a little bit for you, and then this light between 300 to 400 nanometers is what is going to be filtered within that ocular media. So on the left, if you look at the curves, and there's a lot of different lines there, don't get hung up on trying to actually read the different lines, but notice the shape. They're all very similar. And we can see, if we pull out just the averages of the white and the brown strains on the right side, that we see a shift over time. And so roughly between every age that we sampled, we saw a 20 nanometer shift in that wavelength that goes through that ocular media. So what does this tell us? Birds' eyesights are likely getting worse with age, which would be no different than what we experience. So that's good to know. So if we look at the different densities, and again, the 4 or the 5 different types of the photoreceptors, and you can see brown and white, 17, 25, and 85 weeks of age. The important thing to note is that the VS, or the violet type, which is the first short bar, all of the photoreceptors are normalized to it. So that's why they all look the same at 1, but then you can see the other bars vary in height. The important thing to notice here is that as a result of this, we know our brown birds don't have as many photoreceptors density-wise within their eye as the white birds. So we know there's now a difference. So A, we know that their eyesight's going to get worse with age for both brown and white birds, and we know that brown birds have a different density of photoreceptors than white birds. But it is conserved across time, so it's not like they're losing them throughout their life. So then when we look at the actual absorbance, and you can see the brown and the curves there for the different wavelengths as they're being absorbed by the droplets, right there in that section around 450 nanometers, there is a shift. And so when we pull it out here on this side, you can see it shifts from 444 to 462. So now we know that not only do brown birds and white birds have a different density of those photoreceptors, they actually have a shift between white and brown birds for the nanometer wavelength that is being absorbed or that they can see. So we're lining everything up to say that we now can, from a visual standpoint, acknowledge that white birds and brown birds do see difference. And again, when we look at the oil droplet absorbance, you can see the very different curves between the brown birds and the white birds. Okay, so that's at least the grounding of more of the physiology, the anatomy of those eyes. But what does that really mean now to something that can be applicable for how we want to think about things moving forward? So what we are now working on, and we continue to work on in various grants, are perception models. The idea behind this is that if we take whatever the ambient light is in the upper left corner there, so in this room, whatever the light is, we know that if we're trying to look at myself against the flag in the background, there's reflectance of me in my shirt. There's also reflectance then of the flag. So we have to be able to, or the birds have to be able to differentiate between my reflectance and the flag's reflectance, We factor in all of the visual characteristics that we just talked about, and then we have to say, okay, what does that actually look like for the birds when they receive whatever message it is into the brain? So a more simplistic way to think about this, okay, so we have A, which is whatever light is coming down. It's going to reflect off of the RS, which is the reflectance of whatever we're looking at. We have the RB, which is the reflectance of the background. We have the distance or the transmission of that message, which is the T, and whatever then is received by the birds, the receiving bird, that puts together the word arts, right? So that is the message that is being delivered, and we can influence, depending on the length of that distance T, as well as the reflectance of the birds or the light source that we're using. We can have lots of various places we can influence those messages between the different birds. So when we think about, we talked about the 4 versus the double-coned photoreceptor. And so when we talk about the chromatic contrast, we're talking about the ability to differentiate in that first, the red square with the yellow dot in the center. And as we move it from high to low, we can see that that yellow dot becomes lost as the squares change color. So that's the color contrast we're trying to get at. The achromatic contrast, or the brightness, or the ability to see motion, same concept. That black circle inside the gray box, and as that gray box starts to change, we can see we can get to a point where we cannot differentiate the black box from the black circle. So now, if you only knew this, and you think about some of the things we do in the production house. If we have pecking behavior, what do? We dim the lights, right? So we're changing not only the light coming in, we're changing the reflectance of the birds, changing the reflectance of the background, and we're playing with the color contrast and the achromatic contrast. We're playing with all of it all at once, and all we know is the behavior stopped. But yet we don't understand why the behavior has changed. So when we think about it, so not only is this very simplistic about everything I've talked to up to this point in time, but now we can start to play with our lights, because we have this wonderful thing called LED, which allows us to give lots of different colors within the spectrum. So what I want you to notice on this is if you look at that brick wall underneath those different lights, you can see changes in the texture. Some lights accentuate the texture, others make them look more smooth. So when we think about what Karen just talked about, she's doing some of that by what those birds are being exposed to from how they process those visual signals going into the brain. Some things may pop out, such as other conspecifics or other birds. Others may completely disappear. They can't see them at all. And it's only because we changed that wavelength coming into the pen. So when we talk about some slides coming up here, it's important to understand that when we talk about birds, they talk about the just noticeable differences, or the JND. And what that means is it's a spectrum where 0 means they can't distinguish it from the background, so it's all one big mass. If we get to between 1 and 4, they can in fact differentiate it, but it's probably hard for the birds to see it. And if we're above 4, then that means they can easily see it. And the higher it is, the more easy it is for them to be able to differentiate the two different things that we're talking about. So 4 is the important number for you to remember today. 4, if it's above 4, it's good. If it's below 4, we got to work on it. So now let's put this into practice. What is this? An egg. Okay, right? We can see this. So a brown egg on a litter background. But if we walked into the chicken coop, depending on how bright it is, we would be able to see that. Now, the way these are going to be set up, and you're going to see several slides like this now in the upper right corner, I'm going to tell you if it's chromatic or achromatic. So we will always talk about color first, and then we will talk about the brightness. On the left-hand side is the JND. And remember, what's the number I asked you to keep in mind is most important? 4, excellent. So we're looking for 4. And to make it even easier, I drew a gray line, which is right below the black line of the TVs. So don't look at the screen line, look at the slide line. Then when we look at all these bars, we're not going to go through all of them all the time, but to orient you, the first 3 bars are going to be your brown birds, followed by your white birds, and then we have them 17, 25, and 85 for the different weeks, okay? So we're not going to jump down all the way. The more important things that I want you to notice is when they can or can't see things when we put it through the perception model. Keep in mind, this is the perception model of what the bird can see. Now, we played around with some different lights because that's what the perception model allows us to do, is to say, okay, we want a red light. And so we can then specify the wavelengths coming in on that red light, and then we can run it through the model and see what allows it to pop or not pop. It's always going to be the object that we're trying to find or that we're trying to differentiate from the background. So on the left side, you can see it's an egg versus a bare floor, and bare floor is just concrete. So when we look at the egg compared to concrete, we can see that for everything other than a green LED light, birds could differentiate a brown egg against concrete. Now, when we have used litter, which is the picture I just showed you, now we can see it doesn't really matter what light source we have. Brown eggs, even if they're a more dark brown or a less brown compared to the darkness of the litter or lightness of the litter, that brown on brown, birds can't differentiate. Maybe they can, but not very easily. Now, when we talk about achromatic, right? So that was just the color. So now we're talking about the brightness. So how bright in the grayscale is that egg compared to the grayscale of the litter? And again, we can see when it's bare floor, only if we move to a red LED does it really pop for birds to be able to see that egg in the grayscale. And when we move to a used floor, again, only under that red light are we going to see that egg as a bird. So, at least for me, when I'm starting to think about some of the mislaid eggs that we see within the housing system, how much of it is the nesting behavior where, wow, my sister just laid an egg here, so now I'm going to lay an egg here, versus they see the egg there, now they want to go lay there because there's already an egg there. It starts to make us rethink about some of those behaviors that we see. Now, this is at a commercial facility, and they had a steel post in the middle of the house, a couple of them throughout, right, to support the second floor because it was a 2-story aviary system. So we'll talk about the steel post, and then we'll talk about the ramp and the perch. So when we look in the color again, if we take that steel post and we look against a wall, and the wall was just a white wall, it didn't matter what color light, birds can't see that steel post when they look at the steel post in the front and the wall behind it. They just can't see it. And if we look at the perch against the ramp, they absolutely cannot see it again. So it's just a mass when they try to differentiate it from a color perspective. However, they can see that that post in the black and white, or the grayscale, right, that it is different from the wall. And it doesn't matter under what lighting condition we put it. And if we look at the perch and the ramp, it doesn't matter what light we use, they still can't do it. So now start to think about the fact that, okay, if we have a stainless steel perch and a stainless steel ramp, do we have to be concerned that the birds can't see it, and so maybe that's why they're not using it? Or when they think they're jumping to something and they really can't differentiate it from whatever is in the foreground or in the background, that's why they miss and they fall. So now it starts to change how we may even want to think about designing things. So this is our research facility, and so to give you an idea of the color of the wall that we're going to compare against and the metal perch. So when we use the wall, trying to understand, could the birds see this is where the wall and the floor come together? So in this scenario, it doesn't matter what color of light we use, they cannot differentiate very easily the wall from the floor. So I guess they don't want to run too fast because they could just run into the wall. And when we look at it then with that grayscale, they can differentiate the wall and the floor. So they do have some sense, and that's what I think is the hardest thing for us to wrap our head around, because we are used to seeing in color. Those that are colorblind or those that have issues with color probably understand it better than those of us that have full sight, because it is very hard to wrap my head around the fact that I can see something in color, but maybe I can't see it in color, but I could see it in gray and white, or black and gray, or whatever grayscale you would like to use. So when we talk then about the way that we design our different pieces within our housing system and put them together, what does that look like? Well, when we talk about a blue feeder against the floor, very easily seen. So that blue makes it pop, same with the red. And you can see here when we get into the green lights, or sorry, the blue lights, that we see that it's not quite as difference, but it's still different that they can see it. So then you start to think about how we have designed all of our things we use when we brood chicks. What colors do we use? They fall within the colors that this says they could easily see. So that doesn't surprise us. We did it. We may not have known why we were doing it, other than we got good performance. The birds seemed to go to it, but this is why the red nipple drinkers, the things like that we use. However, if we take the ground feed and we put the ground feed on the floor, on the litter floor, they can't differentiate it from a color. But I would argue that even us, if we would take ground feed and throw it across, would struggle to be able to pick out the ground feed from the used litter. When we move into that achromatic, so the egg farm LED lights for the blue feeder versus the used floor. So that was a company, eLumigen, that came to us and said, hey, we want to know if you'd use our bulb. Sure, well, I don't care. It's given us full spectrum. We'll try anything, right? We didn't see any difference in production or anything. But when we modeled it with the blue feeder against the floor, then all of a sudden it didn't pop so that those birds could see it in that achromatic. Red feeder, chicken feed versus used floor. That one's more interesting, right? Just because we can't see that chicken feed in the used floor, in the grayscale, the birds can differentiate the feed from the litter. So the reflectance to the bird is going to be very important, not as much for how we may see things. So then when you start looking at the internal for the nipple drinkers, or even could they differentiate the top of the pen, right? Depending on what you see on what tier within that aviary system, it may change how you perceive some of those resources. And this is why I love working with biologists. So the drinker spigot, okay, yeah, I think we all know what the drinker spigot is. So the pin meter drinker, or the nipple, right? That compared to the orange drip cup, they can see that only under the blue light. Otherwise, they couldn't differentiate it. If we look at it against the wall, they can't see the difference at all. And then when we look at it as the orange drinker catch cup compared to the wall, then that pops. So the actual, what they're calling the drinker spigot is the actual metal nipple, is what they were making that comparison to. And then when we move it into the achromatic, it doesn't help us at all with the actual metal aspect of the nipple drinker. But when we move into the catch cup, obviously they can see it very easy in that achromatic stance. So it's complicated, right? That's what it boils down to. For us to try to imagine what it's like for those birds to visualize their environments is complicated. So we have a grant currently, and Greg is on it, as well as Esteban and several other people at Purdue. We're trying to look at some modeling, and this came up during one of our discussions as an interesting behavior that they were observing with the hens that we were pulling the data from. Now, what you can't see because of the way the lights are is that there is a shadow on that wall. And if we talk about everything that we just talked about related to color and related to that achromatic, I wonder if they think it's an actual ledge at which they can jump onto. Because they visualize it so very differently than we do. We're just like, wow, look at that weird behavior. I wonder what's going on. So I think from the standpoint as we continue to better understand our bird vision and how they actually visualize our environments, we're on that cusp of really being able to rethink our entire production systems and what it may look like when we start to design them for the chickens and not just for us. So I don't know that we'll get to this point where we're going to ask all of our birds to take an eye exam so that we understand how they're visualizing everything. But I think now that we better understand that we have those differences between white birds and brown birds, at least for laying hens, I don't know that I would necessarily feel comfortable that we could say it's going to apply to broilers or it's going to apply to layers or to ducks. That there are enough differences amongst our avian species that this is going to help move us one way, but we may need to actually step back and do just some of the groundwork again with our different species in order to better understand how to design those housing environments for them going forward. And with that, thank you very much. I'll take any questions.
All right, very interesting. We do have one online question, which we'll start with.
We have a question from Kenneth Powell. Interesting talk on what chickens see. Using LED lights now in breeders, one thing that has stayed the same is the use of the infamous gray nest pad, which was determined as the best for natural light for getting birds to lay in the nest. Should we revisit this color of nest pad?
So when we talk about the nest pad, and part of the grant that we're working on right now is we want to get to the point where we can actually model all of our various components in a housing system so that we could say, okay, if we had a gray nest pad compared to a red or to a green, how will that change how the birds use that system, right? So at this point, I don't think we can say we need to make changes versus we need to better understand how they actually visualize what they see. So it may not be the fact that it's a gray nest pad. It may be more about the way that the nesting area is designed and how the birds see that nesting area that may attract them to use that gray nest pad, but not the fact that it is a gray nest pad.
Thank you very much, Dr. Karcher. I'm interested in how light intensity will play into all this differentiation because say we have feather pecking outbreak, we bring the lights down. Is that then going to compromise welfare in terms of more risk of injuries because they're not able to see the perches as well or that kind of thing?
Yeah, so it's a great question, right? When we start playing with intensity, because at least with laying hens, I would argue that we need to do the complete opposite of what we've always done, which is keep it dark, especially as we move into an extensive housing systems. I actually think they can navigate better if they had more light so that they can more clearly see the different things we're asking them to go through in that environment. What we're trying to better understand is, can we increase light intensity at the same time play with the wavelengths so that maybe your sisters don't pop out as much, but you can better see the environment to navigate. So I think we're on that cusp right now of being able to look at things more complex and not just say, well, I want a blue light. Maybe I need more of a white light, but I need these certain nanometers dialed in. So to us, it still looks the same, but to a bird, it may be so very different that this room to them looks night and day different, but to us, it still just looks like the room.
I have a question. Hi, Darren. So, do you think there could be a relationship between the relevance of those objects to the birds and how quickly they could recognize them, like the egg versus the metal pole that you saw in the facilities, and if that could impact, yeah, their ability to see them?
I do, especially knowing after we saw some of this preliminary data as we work to refine the models, if the stainless steel environment ramp compared to a perch versus stainless steel floor or that metallic color, right? If they all look the same, perhaps we should be thinking more about, do we need to color them differently, right? Metal is, the reason it's metal color is because it's cheap to keep it metal color. But if we can change how they use their environment and say reduce the amount of floor eggs or reduce keel bone fractures or breaks as a result of making all of our perches bright pink, then perhaps we need to color all of our perches bright pink so that the birds can see them to more clearly navigate. So I think as we continue to play with these whole perception models and trying to better understand what it may look like to really see that environment for those birds, that's what I'm hoping, is we get to a point where we can say, okay, if you have this type of lighting, here's something you can plug in some information, and then here are some recommendations that we feel pretty confident could help you have an influence on that overall welfare and behavior for those birds.
How are you going to change the color of the eggs? Just kidding.
Ha! Wash them.
Oh, when you showed that last sequence of birds that were jumping from the floor up to the wall, there seemed to be one bird in the foreground and then one bird way back in the other that seemed to dominate, and the other birds were just watching these two birds. I mean, is this something that can be controlled, or what is it that makes the one bird seem to keep trying to jump and the others are just watching? They're not doing anything.
No, I think that's a great question, right? Because so the other thing that we're trying to wrap our hands around right now is not only are we trying to visualize their environment, but also how they visualize each other, right? So are there subtle clues? And the question I would have then is, if you look at that population and you start to look at network mapping, was the one that was more dominant or more of your alpha, was that the one that was trying to jump up to either illustrate to others, here's something to think about, or conversely, were they at the bottom trying to get away and they're all like, you fool, what are you doing? You're still stuck, right? I don't know. I think there's just so many things we don't know, but I think it's so fascinating to now think about trying to look at everything from their perspective as we move forward.
Anyone else have? I could ask you about 14,000 questions. Most burning, I would say, is talking about some of the issues that we see with poultry where we have no idea why they're doing what they're doing. The first thing that comes to mind is piling behavior. And I think there's been some recent research lately to suggest they might like it. So I've been calling it a mosh pit lately because it seems that there's some members that leave and some that come. Do you think that it's related to the visual system at all? Is there something that's visually stimulating about it?
So we've had this conversation not just within our group of who's working on these projects, but also with some industry folks, right? Because we see something similar with laying hens. They're calling them chicken eddies now, right? Because that's what they form out in the middle of the ocean. And then they just disappear. And so trying to understand, is it a visual cue, right? Is there something there that we can't see that they visualize and it draws them all in? We've also had conversations around temperature gradient. So is there something from a temperature standpoint that is pulling them in? And that's why you see some leave, because whatever they're looking for or searching for within that temperature gradient, certain ones are looking for it, they're finding it, so they keep coming, and others come because everybody else is doing it, but then they leave because it's not anything that they need. And so at this point, I don't know that we can say it's one thing versus as we really continue to understand the different physiological systems of those birds and how they perceive their environment, we may get to a point where we can better understand that exact microclimate that is resulting in whatever piling behavior, eddies, whatever issue it is that we're trying to really assess and better understand.
Oh, I'm gonna keep going here. If no one has any questions, let me know. Gonna go a little deep into maybe some philosophy here, some unknown territory. I listened to a podcast recently about how over half of the population today has some kind of visual impairment, and they linked it to reading, essentially, that people today are more nearsighted for reading and writing and hunching over a desk all day like we do sometimes. And I'm wondering if you could speak to, or if you thought about, which I'm certain you have thought about it, if you've thought about kind of how we've domesticated laying hens in this case, and how we may have also selected artificially their visual system.
So I think the question is, A, they don't read, so I don't have to worry about them being nearsighted. However, yeah, maybe. So, however, we have selected birds to perform in a conventional cage environment. And so pretty much we're asking them to go no more than 2 to 3 feet in an entire circumference, and being able to identify that feed and water and interact with all of their flock mates. Genetics companies, conversely, have been selecting or trying to move to more of a population selection procedure so that they can see how all of those individuals within those pens or within that pen or that unit interact with each other. Couple that then with the fact that when we look at industry, they're going to have, you may have a house where it's got 90,000 birds that all run together versus a 90,000 bird house that are subdivided into groups of 3,000 birds. There are so many different variables that play in that I don't know we can say that we have selected pro or con against a visual system, because we do not have a consistent way at which we are trying to even evaluate it, right? So just because we put 500 birds in the selection pen, they all seem to have the temperament we want. They visualize everything we think they need to have. When we then take the progeny and we put them into a production house with 90 or 89,999 of their sisters, and they're trying to visualize that environment, I think it's not so much the selection of the visual system versus all of the things within that production environment that change how they perceive it. Go ahead, Greg. Oh, excellent.
The things we don't know about the bird retina is just amazing. There is a whole nother set of photoreceptors in their eye that haven't talked about at all, because we don't understand them. They're called the cryptochrome photoreceptors. They are an ultraviolet photoreceptor that also, through an unbelievably complicated biochemical process, allow birds and other animals to perceive magnetic fields. And so this is very important for migratory birds. And we do not understand how these cryptochrome receptors, I know it's something I'm working on in my lab, I know chickens, ducks, and quail have them, but how it affects their behavior is extremely complicated and controversial. But, you know, there's a whole aspect to the bird retinas that we don't even know how to deal with. And the magnetic fields are not just the Earth's magnetic fields. Anything with electrons, electricity coursing through it gives off a magnetic field. So how are LED lights impacting that in a little tiny space like a net box versus the open floor? So just more things we don't know that we can't account for.
Thanks, right? Any questions? Oh, that's good. All right, I'm gonna ask my question on the way. Speaking about the age effect, so I know that when I don't know if it's cataracts, I don't know if the 85 groups is fairly old, but maybe not. Issues. But the age effect, it didn't really seem like there was much of a reduction in any of the many figures that you showed in terms of the light and dark contrast. Can you speak to that a little bit?
Yeah,
The general
so-
age effect?
So beyond that shift in the ocular media for how they're bringing in the wavelengths, at least everything else is suggesting that that appears to be the major change for their sight and how they may perceive things. But when you start talking about the perception models and looking at the color and trying to factor all that in, it's a very slight change, but it does change over time, right? Which may mean that as we move forward, we may have to think about changing how we light our birds at certain stages of life to make it more easy for them to see something as they're getting older.
Absolutely, thank you.
So I'm curious on your thoughts on so many of these birds go outside now. So they go from basically a brown gray world to Univision or color tech or
Yep.
whatever you want to call it. So what's your thought on that? What are they seeing when they step outside?
Well, that's what I think is real interesting, right? So when we even just watching the behavior of brown birds and white birds outside and how they perceive predators, aerial especially, I'm wondering if some of the things that white birds will tend to give that alarm call very quickly and change the behavior where the brown birds tend to stand there a little bit before they finally decide it's a threat. I wonder if it's because it's beyond that distance at which they can really see whatever that aerial predator is. And so it takes a different threshold to trigger that behavior to say, hey, we have a problem here. I think that, and this is part of why I said, I think we can go to full light within our production environments, at least for laying hens in extensive housing systems. Birds seem to be fine navigating going from a controlled climate outside, and we know that the lighting is night and day different. We also know that if we have a day where it's not full light like it is outside right now, but it's gray and overcast, that's when birds absolutely love to go outside. And I think it's because it changes that spectrum of light coming in, so it changes all of their filters in what they can see, and so they see things more clearly without having that bright light. The other thing that we didn't really talk about, but we're all aware of it, all of our eyes are mounted right here, and chickens are on the side, right? So we know that they also, for us, while it may not seem that it's overly bright out, for them it may be very bright or conversely the opposite. We think it's super bright and maybe it's not quite as bad for them because they're having to receive, and when we talk about that foreground and background, it's the foreground of one eye and the background of the other eye, right, is how Esteban described it, is how we can think about it, right? They're bringing in two messages, and so it's trying to put both those messages together at the same time. It's not always just one message from a single eye. So yeah, I don't know. I'm excited about all our potential areas of where we can go here in the next 10 to 15 years.
Well, I can remember a comment that you made to me 6 or 7 years ago where you said, wouldn't it be cool if you had VR goggles and you could
Yep.
see like a chicken? And I said, well, how are you going to do that? And he said, I don't know, but wouldn't it be cool?
Right, exactly.
So I expect that in about 10 to 15 years. Thank you, Darrin.